Hey everybody, in this video we're going to verify a bunch of trig identities. I'm going to do as many as I can in about 10 minutes and then I'll break it up into another video. It looks like in our study guide here there are 6, 12, 13, 14 of them, and I have not, don't mind the old table I have this on, mantle thing. I have not looked at them yet at all myself personally. So they're all brand new to me, although I've probably done them a million times over the last 20 years plus. So let's go. Buckle up. Okay. Verifying following identities, work only on one side, All right, I'm going to change the left side because I like to take the messier side. Cosine of alpha, you stay there. Secant of alpha is the same as 1 over cosine of alpha. That's going to come in more handy. Tangent on bottom is the same thing as cotangent on top, and that's going to eventually equal that. Now, this and this simplifies down to 1. And I would normally change my cotangent into cosine over sine. However, cotangent equals cotangent. Looks good. Next. This next example, what I would do is change, probably instinctively, I want to change the left side, because I would rather take something that's a sum or a difference and turn that into a single product than to take something that's a single expression product, whatever, and try to turn that into a sum or difference. Sometimes it's easy, sometimes I don't know. So just if I had to give general advice, right? So first thing I'm going to do is rewrite is 1 over cosine theta, sorry, that's a theta, minus cosine theta, which is really over 1. I'm going to get a common denominator. I'm going to multiply this guy on top and bottom by cosine theta. On the other side, I still have sine squared theta, secant theta. That will stay there to remind me of what I'm working towards. Next, I have 1 minus cosine squared theta all over cosine theta, reminding myself that I need sine squared, which is my numerator, times secant theta, which is the cosine on bottom. So we're basically right there. So this piece here becomes sine squared theta right there. And then the cosine can come up and become secant theta because of the reciprocal identity. And that means we have sine squared theta, secant theta equals sine squared theta, secant theta, check, and we're done. Next, let's go, number 39. Again, same advice as I gave in the last example. I'm going to work with the left side for the same reason. So I'm going to rewrite using sines and cosines. I know you're going to be tempted to rewrite using secant and cosecant. So then you might write secant beta over cosecant beta plus cosecant beta over secant beta. The problem with that is you won't get a good identity to work out. But if you have sine and cosine, you're, spoiler alert, I already know, you're going to get sine squared plus cosine squared, which is 1. But you don't have an identity that uses secant and cosecant, so you'll kind of get stuck and it's going to take a lot of steps. So if you do it my way, it'll be faster. What's that? Sine beta over cosine beta plus cosine beta over sine beta equals eventually secant beta cosecant beta. Now I'm going to find a com denom. So that means I'm going to multiply this one right here on top and bottom by sine beta. I'm switching the colors so people could say cosine beta, cosine beta. A lot of you guys rush this step and you multiply by the wrong thing on top and bottom. I have no idea what's happening. It's a little bit concerning, just saying. Sine squared beta plus cosine squared beta. That's what that is. That's what that is, all over sine beta times cosine beta equals secant beta cosecant beta. Okay, next. This whole top, Pythagorean identity, is 1. Sine beta cosine beta. But sine on bottom is the same as cosecant, and cosine on bottom is the same as secant, so we're right there, right? Next thing, all I have to do is write down, cosecant beta. So I have cosecant beta, secant beta equals secant beta cosecant beta. This is commutative property. I'm not even going to waste my time. I hope you know how that works, right? Easy peasy lemon squeezy. Next. All right, this one's kind of fine. So I'm going to take the left side. I'm going to FOIL out everything. So I have sine x cosine x, plus times sine x plus cosine x, and I want to prove that it equals 1 plus 2 sine x cosine x. So it's, guys, this is like I've said before, like chess, you gotta be 10 steps ahead, If I FOIL this out, I'm going to have sine squared for first. I'm going to have cosine squared for last. That's going to equal 1. My outer and inner is what's going to make the 2 sine x cosine x. We're right there, you know, we're almost done. So first times first, so sine squared x plus, if I write it out, sine x cosine x, inner plus sine x cosine x, I put it underneath because they're like terms, plus cosine squared x equals apparently 1 plus 2 sine x cosine x. Next step, sine squared x plus cosine squared x, I just kind of turned it around, like bring this guy over there, plus 2 sine x cosine x is 1 plus 2 sine x cosine x. Then this right here is 1 plus 2 sine x cosine x equals 1 plus 2 sine x cosine x. If they really wanted to make this problem a little bit better, I would have done 1 plus sine 2x, the double angle identity for this part and this part, but it is what it is. Nobody used it. We just left it like that, you know? And check, we're done. 2 more to go. We're only about 6 minutes, 10 seconds in. Cute. So, obviously I'm going to use the left side again because the right side is a bit silly. Where am I going with that? You know, it's a 1. So, here I'm going to basically do, okay, if you look, this is a bit, I feel silly, I'm about to rewrite all this, but tan y plus cotan y is essentially 39, tan b plus cotan b. I'm going to get it to this right here, and then it's times this, which will be y's instead of v's. It's 1. Can you see it? I hope so. So I'm just going to go kind of quickly, right? So not touching that. Sine y over cosine y, leave some room, plus cosine y over sine y. This is going to get multiplied on top and bottom by sine. This is going to get multiplied on top and bottom by cosine. That gets me my common denominator. Okay, and there's equals 1. Next, sine squared y plus cosine squared y all over cosine y sine y times sine y cosine y. Those cross out, those cross out. That is 1 equals 1. Done. That's 41. Finito. Last one in this page. I guess we'll see how far we get. But here we are. Okay. I'm going to use the left side again. It's just coincidence. I don't know whoever set this up. 1 over sine theta minus, I'm rewriting using sines and cosine, over 1 over cosine theta minus 1 over 1. Okay, I'm going to multiply it on top and bottom and clear out my fractions. So it's sine theta cosine theta on top and bottom. So I'm multiplying by 1, and I'm going to eventually hopefully get this. So let's see what happens. Trust the process. This is going to distribute to there. The sines cross out. 1 times cosine, I get cosine theta. Minus sines cross out, I get cosine squared theta. In the next step with this numerator, I'm going to factor out cosine theta and have 1 minus cosine theta inside, okay? Bottom, this, the cosine crosses out. I'm left with sine theta minus, that's just sine theta cosine theta. On the next step, I'm going to factor out the sine and also be left with 1 minus cosine theta again. And then those will cross out, and I already see where this is going. So this is going to be cute. We're going to be fun. So next step, just scooch my paper a bit. The top, the GCF is cosine theta, 1 minus cosine theta, over factor out a sine theta GCF, 1 minus cosine theta. Okay. Those cross out. Last step, cotan theta equals cotan theta. Done. That's it. That was number 42. 9 minutes, 17 seconds in. Do I have time for one more before about 10 minutes? Maybe. This one looks similar to the last one, so let's go for it. I'm going to do the left side again. So I have sine alpha minus 1 over sine alpha over cosine alpha minus cosine alpha over sine alpha. Clear out my com denom situation, so multiply on top and bottom by sine alpha. Eventually we'll get cosine alpha, 1 minus sine alpha. This distributes, I get sine squared alpha, not theta, whatever, alpha minus 1. That is negative cosine squared, right? It's the Pythagorean identity. Then here, cosine alpha, sine alpha, minus sines cross out, cosine alpha. So similar to the last one, I'm going to be able to factor out a GCF, 1 minus sine alpha. So on top, I have, on top, I have negative cosine squared alpha. On bottom, I factor out a cosine alpha. That leaves me with sine alpha minus 1. So sorry, it's squished like crazy. Equals cosine alpha, 1 minus sine alpha. Okay, from here, okay, that negative I'm pulling out front. The cosine squared, I'm going to cross out one of those cosines with that cosine. So I just have cosine alpha on top now. Over, if I take that negative that's here, okay, I'm going to distribute it to the bottom. That becomes a negative sign plus 1. 1 minus sine alpha if I turn it around. And that, in fact, equals itself. Just replay that part if you need to hear it again. But that was the end of 43. It's 11 minutes, 25 seconds. Ah, too long. Check the next video for the next bunch of this set. These are the ones that are on the screen right now. They're going to be the next 3 I'm going to do. Questions, comments, concerns, requests in the comment section. Thumbs up if you're kind. And see you in the next video. Bye.